Good day, ladies and gentlemen. This is Sarah van Gr12, aka Mr. VG, and this is video 1 in our series looking at Mathematics Paper 2, Statistics and Data Handling. This section will be covering last year's Paper 2 that was written in November 2021. So if you're looking this in 2023, you know that is 2 years ago, if you can do the maths. I hope so. Well, please join me in this video where we are going to start discussing statistics and data handling. Now, I know some of you very strong mathematical learners might look at this and go, oh, so I've got this covered. I encourage you, watch this video because I'm going to be discussing some of these finer things about statistics and data handling you might not be aware of. So please lean in, look at this, and enjoy the video with me. In this video, we are going to discuss this specific question. Question 1 of last year or November 2021's matric exam paper. Please hit the pause button and try and do it yourself. When you have tried it, you come back and then you look at the rest of the video. This video, we are going to specifically look at these small little fine things that we tend to forget about when we do statistics and data handling. First of all, we are going to use these formulas, although it's very seldomly asked that kids use this video. The IEB students, oh my goodness, just want to say, in the past year or two, they've actually gone and asked questions about that formula. Okay, we're not very much familiar with the formula. We don't do it in detail anymore in the normal day-to-day mathematics, but they have actually asked it. So you, IEB, maybe even GDE, we're not sure. We never know what rabbit they can pull out of the hat. But for this video, we are specifically just going to look at answering the questions. Question 1.1.1, it says, calculate the mean number of loaves. So in other words, x bar is equal to sigma of fx over n. In other words, adding all the different values together, dividing it by 18, 22. Let's just quickly stop for a moment. What does that mean? That means if I had to randomly pick a day, then I would expect there to be 22 loaves of bread ordered. Or on the next day, I want to know, how many breads do you think I'm going to sell? Well, I expect 22. So the mean is fantastic when working with this. Is it good? Does 22 the value? I don't know. You don't know until you start investigating deeper. What is the norms? What is the average for this kind of shop, for instance? This could be fantastic if you compare it to another shop. So the power of statistics really comes to the fore when you are comparing the data sets with one another. I'm not going to do that. I'm just going to look at answering these questions, and then we're going to talk a little bit more detail. So please feel free to use your calculator, the stats mode, to answer 1.1.1 and 1.1.2. You don't have to show the examiner this, but you can just write that down. I'm fine with that. Same with standard deviation, 10,17. Fantastic. But now what I want to ask you is, what is standard deviation? Now that is an interesting question. Well, if you think about the word deviate, where deviation comes from, that means going away from. So the standard, the average, by which the data sets deviate from the mean, which means, and I like to think of it in this way, that if I take the mean and I take one standard deviation above and below the mean, then first of all above, and second of all below. That is where the majority of your data set will lie. That's basically what standard deviation tells me. It's this band, this area where the majority of the entries will lie. Is this the truth? Well, let's have a look. There's 11 out of the 18 that lie between negative 11.83 and 32.17. But what does standard deviation really tell you? Standard deviation is about consistency. It's about, is the or are the orders erratic? Meaning one day you have a lot and one day you've got nothing, then you have a lot again, then you have nothing, or is it all kind of lying close to the mean? Well, we don't really know if it's good or bad, this 10,17. But what if I compare it to a data set that, say, has a sigma of 15? That means the majority of the data lie between 37, let me go to, and let's go one standard deviation below. So if I subtract that 22 or 15 from the 22, I get 7, which means the second bakery, let's say this is the second shop, which has a standard deviation of 15, which means the majority of their loaves ordered lie between 7 and 37. So they have lower number of loaves ordered on a regular basis and also higher. So one day they could have 37 and the next day they have 7 and the next day they've got 32 and the next day they have 8 again or something like that. Which shop is more consistent or the orders are more consistent? The first one with a smaller standard deviation, because their standard deviation is smaller, their data lies closer to the mean. And this is where the power of statistics come in. Statistics comes in comparison, comparing two sets of data with one another. Oh man, I could talk about this the whole day. But let's go on to question 1.2. Now question 1.2, I'm just going to redraw this band that we have with a below and above the mean, because 1.1.3 it says the number of days on which the number of loaves ordered was more than one standard deviation above the mean. So in other words, one standard deviation above. That's why I'm just going to be looking at above. So if I look at the data set, which of the entries are above 32,17? 35, the 37, the 40, and the 41. So that means 5 out of the 18 lie above the one standard deviation above the mean. They could have asked for percentages as well. Then I would have just gone 5 over 18 times by that. Interesting, definitely. What does this really mean? We can say this was exceptionally good days, not necessarily outliers. That's a different story, but very good days. So 5 out of the 18 was really good days for them. Let's look at the next question. The next question now asks, the tuck shop owner was not able to sell all the loaves of bread delivered daily. He calculated the mean number of loaves sold over the 18 days to be 20. Okay, so now we're comparing mean. Okay, so calculate the number of loaves of bread which were not sold over the 18. So he ordered a number of bread, but only sold a different number. Okay, So let's compare. What did he actually sell? Okay? Or now, this is not the right terminology that I use. It's all the breeds ordered. So let me just fix that one quickly. Okay? So all the breeds ordered. Oh, I'm not writing nicely tonight. Was 22 over 18 days. But the reality of what he sold was only 20, an average of 20 over 18 days. So now, let's look at the actual number, not mean, but the actual number. Well, how much was not sold? Well, that was the breeds ordered minus the breeds sold. So, how many breeds did they actually order over the 22 days? They ordered 396 loaves of bread. Sorry, I keep on saying breads. That's such a horrible English there. Loaves of bread. But if I look at how many were sold, there was actually 360 sold. So that means 36 loaves of bread went unsold. Is there an alternative? Remember your 80 and 90 percenters. You need to start asking yourself, is there an alternative? There is. Let's quickly look at this. I love to look at this. If I look at this, let's look at the mean per day. If I look at the mean per day, the mean per day says that there was 22 minus 20, which means an average of 2 loaves of bread per day went unsold. Why is this? You ordered an average of 22, but only sold 20. So there's 2 every single day that went unsold. If I now go and say, okay, but over 18 days, so if I take this 2 and I times this by 18, that means there was 36 loaves that went unsold. And oh my goodness, same answer. I love how maths, you can approach it from different ways. Look for those alternatives. Let's quickly have a look at the next question. Question 1.3. One of the 2 box and whisker diagrams shown below represents the data given. Okay, so box and whisker diagrams, love it. I'm going to ignore the 2 graphs and I'm going to do my 5-number summary. So my 5-number summary starts with a minimum of 10 and a maximum of 41. That's hopefully easy for you. Let's go and find the median quickly. Well, before we find it, let's see if we can't eliminate any of the graphs. No, we can't. They have the right minimums and maximums. Let's go and do the median. Front, back, front, back, front, back, front, back, front, back. In the middle of 18 and 19. So my median is 18,5. Because I haven't used the 18 and the 19, I'm going to reuse them, because remember I went in the middle of those 2. So I'm going to reuse them to find Q1 and Q2. So Q1, front, back, until I've got the middle of the bottom half, Q1, which is 14. If I repeat the process at the top, front, back, I've got Q3 as being 35. Now I'm going to compare it to my graph A and graph B. Ooh, graph A is automatically eliminated by Q1 because Q1 is 14. But I love to go through the steps for you. But if you see Q1, you could have actually eliminated it by the median already, because the median was 18.5. Graph A is completely wrong. Completely wrong. So which one of the two box whisker diagrams represents the data? Definitely graph B. Give a reason. Well, I can look at the median, Q1, the interquartile range, which is 21, which means that only graph B could be right. Now describe the skewness of the data. Now at this point, it's not, the skewness is not what I want to see in graph B. Because for me, what I love to see just graphically was that it looks something like this. I'm going to draw for you where it's like this. So this thing of that tail not really being long enough means that I'm going to graphically, I don't like it. I don't like to say it's skewed left or right because the two tails are very similar to one another. There isn't a clear skewness to one side. So what do I do now? If I can't graphically interpret it, I'm going to compare the mean and the median. Now, where's the mean of my data? The mean is by 22. So this means my mean is above my median. That is very important. So my median is smaller than my mean. The moment you see that, you know, or you've got a very good feeling in your little toe that my data is skewed right. How do I think of skewness? Is skewness pulls my mean in a direction. If my mean is pulled to the right of the median, so above, I'm thinking skewed right. If my median is, or if my mean is below, my mean is pulled left, and I've got skewed left. So it's about which direction is the mean being pulled. And in this case, it's skewed to the right. Beautiful, amazing, wonderful sums. Ladies and gentlemen, this has been such a fun video for me to make. I hope you learned a few things, or at least one thing, and learn that you must always compare data sets. That's the best interpretation, is comparing data. So, this is Mr. VG signing out. Tune into our next video where we're going to look at question 2 of the November 2021 exam paper. Have a beautiful rest of your day. Keep safe, keep warm, look after yourself. Cheers.